Hey everyone! Welcome back to ZoomInData. And this is episode 12 of our KQL Concepts Deep Dive series. Today we are exploring string search semantics, including tokenization, and the differences between contains, has, their tilde variants, and regex. We are keeping everything pure concepts and interview focused. If you missed episode 11 on predicate pushdown, it's a good one to catch up on. Let's get started. Here is our roadmap for today. String search in KQL uses different operators with distinct semantics. Tokenization splits strings into words for indexed searches. Contains looks for substrings anywhere in the value. Has looks for full word matches using tokenized index. Tilde variants make searches case insensitive. Regex provides powerful but slower pattern matching. Choosing the right operator affects correctness, performance, and indexing. Let's dive into the details. Let's start with tokenization in KQL. Tokenization splits strings into individual words or tokens. Tokens are separated by whitespace, punctuation, and special characters. Tokens are stored in an inverted index for fast lookup. Has and free text search operators use this tokenized index. Tokenization enables efficient full word matching. This is the foundation that makes some string searches lightning fast in KQL. Now let's compare contains and has. Contains searches for any substring within the value. Contains is case sensitive and scans the full string. Has searches for full word matches using tokenized index. Has is case sensitive and much faster on large datasets. Use contains for partial matches. Use has for whole word accuracy. The difference in speed comes from indexing. Has leverages tokens, while contains does raw scanning. Look at this side-by-side diagram. It makes the contains versus has difference crystal clear. On the left is the contains path. Full string scan icon with a little turtle crawling along. It checks character by character for any substring match. Slow on big data, no shortcuts, just brute force. On the right is the has path. Tokenized blocks with a lightning bolt for speed. It looks at pre-split words from the index, finds full word matches instantly, super fast and efficient. See the middle arrow? It shows the performance jump, from turtle speed on the left to lightning speed on the right. That's why has crushes contains for whole word searches in logs. Index tokens win every time. The tilde suffix makes operators case insensitive. Contains tilde and has tilde ignore case during matching. Tilde variants are useful for user-facing searches. Tilde does not change tokenization or indexing behavior. Performance remains similar to case-sensitive versions. This simple addition lets you catch variations like error or error without sacrificing speed. Slide 6. Finally, regex search semantics. Regex uses regular expressions for complex pattern matching. Regex is powerful for advanced patterns but slower. Regex does not use tokenized index and scans full strings. Regex is case sensitive by default. Use I for insensitive. Use regex only when contains or has cannot meet requirements. Regex gives ultimate flexibility but comes with a performance cost on large data. Check out this quick comparison diagram. It shows the classic regex versus has, contains trade-off. On the left is the regex path, pattern icon with a turtle crawling slowly. Regex gives you super complex matching. Think email validation, phone numbers, or fancy patterns, but it scans everything character by character, no shortcuts, so it's slower on big logs. On the right are the has, contains paths, lightning bolt for speed. These use tokenized indexes or simple scans, fast and efficient for everyday word or substring searches. The middle arrow highlights the speed trade-off. Regex trades speed for power, complex patterns, while Hasn't contains trade some flexibility for blazing performance. Choose regex only when you really need those advanced patterns, otherwise stick to has or contains to keep queries flying. Why does this topic matter in interviews? Interviewers test knowledge of string search operators. Common questions include when to use has versus contains, and explain tokenization. Wrong operator choice causes performance or correctness issues. Understanding semantics shows deep KQL expertise. This topic is essential for accurate log and text analysis. Nail this, and you will avoid many real-world filtering mistakes. To wrap up, tokenization enables fast indexed word searches in KQL. Contains scans substrings, has matches full words. Tilde variants provide case-insensitive searching. Regex offers complex patterns but slower performance. Choose operators based on semantics, speed, and accuracy needs. These choices make your text searches correct, fast, and efficient. That's episode 12 done. Thanks for spending time with me on ZoomInData. Next in episode 13, join flavors and broadcast semantics. We will explore theoretical performance of different join types in KQL. Homework to lock this in. Explain to someone or out loud. What is the difference between contains and has in KQL? Think of a log search where has tilde is better than contains tilde. Answer this one. When would you use regex instead of has? If this helped, like the video, share it with anyone prepping for Azure interviews, subscribe for episode 13, and drop a comment with your biggest takeaway today. Thank you so much for watching ZoomInData. See you next time. Keep zooming in on those concepts. Bye for now.